the Leetcode problem number 215, which is kth largest element in an array, the medium level problem. So we are going to solve the problem using Python. Now we'll see the problem statement. 215, which is kth largest element in array. So given an array which is of integer nums and an integer k, return kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. You can solve it without sorting. So whatever the input which they are given as nums, so we should not use the sorting method. So we will see first example one. In the example one, the nums are given with 3, 2, 1, 5, 6, 4, and k is equivalent to 2. Now here the numbers are not in the ascending order. So what we had written is, out of all these numbers, if we sort, so the sorted list we are going to have is 1, 2, 3, 4, 5, 6. And we have to return kth largest. So now here we have to consider the output is which is equivalent to k is equivalent to 2. So that means we need to provide output which is the second largest value. So the first largest value is 6. The second largest value is 5. So we are going to be returned the output as 5. Now in the second example, the numbers are given are 1, 2, 2, 3, 3, 4, 5, 5, 6. And the k is equivalent to 4 here. So in the given nums, after sorting this, we have to retrieve the fourth largest value. So this is first largest value, second largest, third largest, and fourth largest. So 4 is the fourth largest element. So we are going to send the output, or we are going to retrieve the output as 4. So for implementation of this, we are going to use heap data structure. We are going to read one element because we should not sort this. We will read one element that we are going to be moved into the heap. So heap always will give lesser value which are present in the heap list. So first we are going to read 3. So in the heap, first we are going to be placed the value is equivalent to 3. So this is we are going to be considered as heap. The first value will be moved as 3. So after every value pushing into the heap data structure, we will check whether the length of heap is greater than given k. Whenever the element or the number of elements which are present in the heap, if it is greater than k, so then we are going to be pop the elements from the heap. So now, as of now, we are consider only one value which is equivalent to 3 that we have placed into the heap data structure. Then now the length of this heap list is equivalent to 1 as 1 is greater than 2. As it is a condition fails, we are not going to pop the element. Now we go for traversing to the next element. So next element we are having is 2. So now we will move into the heap data structure with the value of 2. Again, we will check what is the length of heap. Currently, we have two elements in the heap. So now we will check whether 2 is greater than 2. As the condition is true, no data will be popped from the heap data structure. Now we will go to the next element, which is equivalent to 1. So 1 will be moved into the heap data structure. So at this instant, as 1 is greater than the length of heap is equivalent to 3, and as 3 is greater than 2, so we are going to pop the element from the heap. So whenever we do the pop operation from the heap, the least value which is existing in the heap data structure, that will be fetched. So 1 will be popped. Now at this instant, we have only two elements. Again, we go for the next element in the nums, which is equivalent to 5. So 5 will be placed in the heap data structure. So at this instant, we are going to have the length of heap is equivalent to 3. As 3 is greater than 2, we are going to pop the element. So previously, what is the element we have popped is 1. So now in our heap data structure, the elements which we are having is 2, 3, 5. Out of these three values, the minimum value is equivalent to 2. So it is going to be pop the element which is equivalent to 2. So from the heap data structure, 2 will be removed. Previously, 1 is popped. Now we go to the next element. The next element is 6. So we are going to be move or push the value 6 into the heap data structure. At this instant, the length of heap is 3, which is greater than the k value, which is equivalent to 2. So we are going to be pop the element from the heap data structure. So in the heap, we are going to have the values are 3, 6, 5. Out of these three values, 3 is the minimum value. So the element 3 will be popped. So once the data is popped, then we are going to have the elements in the heap are only two elements, which are 6 and 5. Next, we are going to be traverse through the nums. So we have one more element which is equivalent to 4. Now we'll move this 4 into the heap data structure. So at this instant, the length of heap is 3 and k value is 2. As 3 is greater than 2, again we are going to be perform pop operation. So when you do the pop operation, out of these three elements which are there in the heap, that is 4, 6, 5, the smallest value will be popped, which is nothing but 4. So after pop operation, 4 will be popped from the heap data structure. So at this instant, we have only two values which are 5 and 6. So there are no more elements to trace out from the nums. So as we are traversed through entire list of the elements in the nums, so we are having the heap is consist of only two numbers, that is 5 and 6. So we require the second largest number. So the first largest number is 6 and the second largest number is 5. So if you see these two values, 5 is the minimum value in a heap data structure. At the 0th index, always we have the smallest value of the entire heap data structure. So at this instant, we are going to be returned the heap data structure which is existing at a 0th index. Similarly, we will see the second example. So in the second example, the nums are given 3, 2, 3, 1, 2, 4, 5, 5, 6, and k is equal to 4. So we want to fetch the fourth largest number. So first we will take a heap data structure. So initially the heap is empty. Now we will traverse through nums. So first we'll take the value which is equivalent to 3, that will be pushed to heap data structure. So what is the condition we are going to check is whether the length of heap, whether it is greater than k. In our example, k is equivalent to 4. So we are going to check every time what is the length of heap after every push operation. After every push operation, we go for checking length of heap. If it is greater than 4, if this condition is satisfied, then we are going to be pop the element from the heap. Now at this instant, the length of heap is 1. As 1 is greater than 4, condition fails. So we are not going to be pop any element. Now we will traverse to the next element. So the next element in the nums is equivalent to 2. 2 will be moved into the heap data structure. At this instant, the length of heap is equivalent to 2. 2 is greater than 4. The condition is failed. So then we'll fetch the third element. So the third element here it is 3. Again, we'll push 3 into the heap data structure. At this instant, the length of heap is equivalent to 3. Again, we'll check whether 3 is greater than 4. As the condition fails, we'll go to move the next element or fetch the next element from the nums. So the next element we have is 1. Now we will move 1 to heap data structure. So at this instant, we have the length of heap is equivalent to 4. So we will check whether 4 is greater than 4. The condition is fails. So then we go for fetching the next element from the nums that will be pushed into the heap data structure. So at this instant, the length of heap is 5 and k value is equivalent to 4. As 5 is greater than 4, we are going to be pop the element. So when you pop the element from the heap, so whatever the elements are existing, which are 3, 2, 3, 1, 2, out of this, whatever the smallest number is there, that will be fetched. So this pop will pop the element which is equivalent to 1. So from the heap data structure, we will remove the element 1. Now we will move to the next iteration. In the next iteration, the element which we are going to read in the nums is 4. Now we will add 4 to the heap data structure. So at this instant, again you can check the number of elements which are present in heap is 5. So the length is 5. So as 5 is greater than 4, again we are going to be pop the element from the heap. So at this instant, when we pop the element from the heap, out of all the entries or all the elements which are present in the heap, the smallest value is equivalent to 2. We are going to be pop the value is equivalent to 2. So when you pop the element is 2, we will remove the element from this element 2 from the heap data structure. Now we will go to the next iteration. In the next iteration, we are going to be fetch the next value is equivalent to 5. 5 will be placed into the heap data structure. At this instant, the number of elements present in the heap is 5. As 5 is greater than 4, we are going to be pop from the heap. So at this instant, the elements which are present in the heap is 3, 2, 3, 4, 5. Out of all these values, the minimum value is equivalent to the smallest element which is present in the heap data structure is 2. So we are going to be pop the element which is equivalent to 2. So now we will remove this 2 from this heap data structure. Now we will traverse to the next element. The next element which we are having is 5. So at this instant, the heap is consist of 5 elements. Again, we will check as 5 is greater than 4. We are going to be pop the next element. So when you are popping this element out of all the heap elements which are 3, 3, 4, 5, 5. So the minimum value is equivalent to 3. So 3 will be popped from the heap data structure. So here 3 will be popped. So we will remove 3 from the heap data structure. Element which we are going to be fetched from the nums is 6. So 6 will be moved into the heap. So at this instant, the values which are present in the heap are 3, 4, 5, 5, 6. The length of heap is 5. As 5 is greater than 4, again we are going to be pop the element from the heap. So if you observe the heap data structure, the heap is consist of 3, 4, 5, 5, 6. Out of this, the minimum value or the smallest element which is present in the heap is equivalent to 3. So we are going to be pop the element from the heap which is equivalent to 3. So we will remove 3 from the heap data structure. So at this instant, we are having the number of elements which are present in the heap is 4, and we are traverse through the entire elements which are present in the nums. So at this end, the heap is consist of 4 entries out of the 4 values, that is 4, 5, 5, 6. The minimum value is 4, which is going to be exist at 0th index. Here, our objective is we had to fetch the fourth largest. So this is first largest, second largest, third largest. This is the fourth largest. So which is we have to send for the output. So we are going to be return the heap which is going to be exist at 0th index. So as it is the index, we will place in the square braces. So this is how we can implement for solving 2-1 by problem. So what are the various steps which we are carried out is first we have to create a heap data structure. So first we create a heap data structure. The second one is traverse through nums. So each num will be pushed into the heap data structure. After pushing, we will check whether the length of heap is greater than k. If this condition is satisfied, we are going to be pop this element. So this loop will be iterated until all the elements are traversed. At the end, the heap will consist of k number of elements. So this k number of elements we are going to be fetched. So with the kth largest element in the array, so we are going to be returned. So what we are going to be written is the smallest element in the heap. Always it will be present at a zeroth index. So that we are going to be written. So now the first step is we need to create a heap data structure. So heap will be assigned with empty list. Now we are going to be traverse through the nums. So for I in nums, so we'll fetch one element from the nums. So this value we are going to be pushed into the heap. So for pushing, we will write the statement as heap q. From this module, we are going to use the function which is heap push. The syntax of heap push is it is going to take two arguments. One is the heap name. We have used heap only for heap name. And what is the element which you want to push into the heap data structure? So that is now. So once the element is moved into the heap data structure, then we will check what is the length of heap data structure. So the length of if the length of heap is greater than k, a given k, if we will check length of heap is greater than k, if this condition is satisfied, we are going to be pop the element from the heap. So for pop the element, we will write the statement. It is in the module heap q, heap pop, and we have to pass only one argument, which is heap data structure name. So once we have done this, then we go to the next iteration. Once the for loop is done, so once you traverse through the entire nums, so at the end, whatever the heap data structure will consist of k number of elements. So to fetch the kth largest value, we are going to be return heap data structure at zeroth index because zeroth index will consist of always smallest number. So this is the code for a given problem which is 215. Now we will run this code. So it is accepted. Now it's submit. It is done. So this is a program for finding out the kth largest index. So one more way we can do here. First we will move all the elements into the heap. So in heap data structure in the Python, we have a method called as heap q dot n largest from the a given n value and the heap name. So this is a method which we can use for the heap data structure where we can fetch n largest number. So we will fetch the n largest values into one array that I'll take as element. So this element will consist of the largest value. So first to largest value, second largest value, like this until n largest value. So in our case, we are going to be find out the kth largest. So in place of n, we'll pass the k value. So whichever it is present at the last element, which is at -1 index, that also we can return. Elements are moved. So then we are going to be fetch n largest value heap q dot n largest. It will take two arguments. One is what is the n value. So in our case, it is equivalent to k from where we have to fetch from the heap data structure. So this it is going to return the value. So that will be assigned to element. So where element will consist of n values. So these n values will be placed in the descending order. So here it is going to return values so that they are going to be stored into the element. So the element will consist of n largest values in the descending order, and we require the kth largest, so which is going to be exist as the last element in the element array. So here we are going to be return the element array which is having the index at -1. That value will be returned and submit. That is accepted. One more change we will apply for the same problem statement. So here we are using a for loop where this for loop is used for traversing to the nums. Each and every element which you are reading from this nums, we are going to be moved into the or pushed into the heap data structure. So this entire thing we can do in one iteration by converting this nums which is of list type into the heap type. So heap data structure. So for converting in this module, that is heap queue, we will call the function heapify, and we want to convert the nums list. So when we use this statement, it is going to convert the nums list into heap data structure. So we will find out n largest value. Now the heap name is nums, so we will pass nums as second argument. So this is going to be fetch n largest value that will be assigned to element. So element is consist of n values. Out of that, we require the kth largest. So all the largest value will be arranged with the descending order. So the kth element will exist at -1 index. Now we will run this code. So this is works fine. I will submit. So it is accepted. Thank you for watching the video. Today we have discussed the problem number 215, which is kth largest element in an array. The implementation